Okay, this video is for my honors higher algebra kids because we have a test on probability tomorrow. We've done a review of most kinds of probability, and so I just want to cover a couple last topics. Let's say that we had some marbles in a bag, and there was 3 red ones, 4 green ones, and a couple blue ones. Some simple questions about this. What's the probability of reaching in and grabbing a blue? Well, that'd be 2 out of, let's see, up to 3, 7, 8, 9. There's 2 out of 9. Okay? That'd be the probability of getting a blue. What if I make it blue or red? Well, then I'm going to take 2 blue ones, or means add 3 red ones, all out of, again, there's a total of 9 there. That would make it 5 out of 9. What if it's and? Probability of getting a red one and a blue one in one draw? It's impossible. All right. And would come in better in a normal situation with like a Venn diagram. I'll do one of those Venn diagram problems in a moment. So I'll draw myself this little Venn diagram to remind myself of that. All right. Next one we're going to do is, what's the probability that I will reach in and get 1 green one and 1 red one if I'm going to take 2 marbles out total, a green and a red. All right, this is a prime case of a CC over C, because in a situation like that, I have subgroups here, kind of like there would be for cards. I have subgroups of different kinds of marbles. I have red ones, green ones, and blue ones. In fact, I might want 3 subgroups on the top. In this kind of problem, you always multiply your C's together, and the order doesn't matter. I said I was going to get 1 green one and 1 red one. I didn't say what order I was going to get them in. If I needed that, I'd do it a different way. All right, but if I'm going to reach in and grab and get a green one and a red one, then I'd have, let's say this is green, this is red, and this is the blues. You might be thinking, wait a minute, why do you have a blue one there? Because you're not going to get a blue one. I'll show you why in a second. If there's 4 green ones, and I'm going to choose to get 1 of them, and there are 3 red ones, and I'm going to choose to get 1 of those. Blue ones, there are 2 blue ones, and I want to choose to get 0 of those. You might think, you didn't need to do that then, did you? I didn't need to, but I wanted to because I wanted it to all add up at the end to these numbers. The numbers that are at the bottom here, those are the things that we are finding are possible that could happen. And these are what we want to happen. And the ones that are possible, anything was possible, so all the marbles, which is 9 of them, but I am choosing out 2 of them. So 9, choose 2, goes on the bottom. All right, so again, the reason I put this last piece in here, right here, is because this way, my 4 plus the 3 makes 7 plus the 2, which I needed to make it equal 9. Now it balances nicely. And the 1 and the 1 and the 0 add up to the 2. All right. Next, let's talk about those these guys, the Venn diagrams. So let's say we had a Venn diagram. And my Venn diagram had these numbers in it. 1, 2, 4, and 3 down here. And that means there's a total of 4, 5, 6, 7, 8, 9, 10 people in this little survey. And these are the people that would choose chewing gum if they were given a choice at like a little airport place to buy stuff. These are the people that would choose to buy some nuts. And these are the people who would not like either one of those options. Right? So a typical question here might be, what's the probability that if I pick one of my 10 people at random that I'd get somebody who likes gum? The wrong answer that people always do for this is they say, gum, oh, that's this one. So it's 1 out of 10. But the thing is, these people like gum also. If you would have picked them and said, do you like gum? They would have said, yeah, I like gum. So then it's really 3 out of 10. If I said, what's the probability I grab one of these random people and they like gum or nuts? I hope you get the difference between or and. If I asked these guys, would you like some gum or some nuts? They would say yes, I'd like some gum. If you ask these people, they'd say, yes, I'd like some gum or nuts. I'll take either one. And these people would say, yes, I'd like some nuts. So if all three of them would say yes, then it's all of those, 4, 5, 6, 7, 8. 8 out of our total 6. No, that's 7, sorry. 4. I had it wrong there. 4, 5, 6 plus one more is 7 out of our 10 people that we could have possibly picked. Okay, so or is a big answer, and it means you put all of these together. If it's an and answer, like probability I find somebody who likes gum and nuts, then you have to ask them each that question. Do you like gum and nuts? And you ask this one person that, and they say, no, I like gum. But the answer was really no, because they don't like gum and nuts. So the ones that would say yes would just be the middle area. They would say, yeah, I like gum and nuts. So that 2 is my answer. It always has to be out of something, 2 out of 10. You can reduce that, of course, to 1 out of 5 and make it a probability, make it 0.2, 20%. If we do a binomial question, these bi means 2, so you only have 2 choices when you do these. And the binomial formula looks like this. So it could be either make the shot or miss the shot. Typically we'll do these like for, let's say there's a soccer guy trying to kick a goal in soccer. And this is, he makes it, and this is he misses it. Let's say that when he gets a chance to have a shot on goal, he makes it about 20% of the time. That means you take 1 minus that for not making, and he'd have 1 minus that is 0.80. Simple as this. They have to add up to 100%. All right. Then let's say that he gets 3 shots on goal during the game. If he gets 3 shots on goal, he gets 3. And then the question would read something like this. If he gets 3 shots on goal, what's the chances that he would make 3 out of 3? Well, then I go something like this. That's how many he makes out of this many tries. This is always the bigger or equal to the other number. This is always equal to that other number or smaller than that other number. All right, so then this one is not complete yet because I have 3 makes, and that means 0 misses, and then I would multiply out 3, choose 3. If you have 3 items and you're going to take them out 3 at a time and the order doesn't matter, which is what that means, then that's just equal to 1. So it's 1 times 0.20 to the third. This part really doesn't matter because to the 0 power means it's just going to equal 1. What if I said he'd make at least 2 goals? If I said at least 2 goals, then that means I'd also be happy with him making 2 goals. And that would look like this. So that would have a 2 here because he made 2 and he missed 1 because the total's 3. And then if I'm happy if he made at least 2, then that means he can make 2 or 3. So this answer or this answer. And I get both answers and I would add them together. All right. So that's how you do. And the other kind that we often ask like this is, let's say that you really need him to make at least 1. Well, then you could do 1 or 2 or 3. But an even smarter way, instead of having to do 3C1, 0.20 to the 1, and 0.80 to the 2, this would work. And then you'd have to add those all up. That's at least 1. But there's only one choice left, and that's 3, choose 0, 0.20 to the 0, 0.80 to the 3. And if it's this or this or this, I could add those all up to do the probability of making at least 1, or I could do 1 minus this, because this really means then if I do 1 minus it means not making 0 is the same as at least making 1. So this one's a pretty easy one to do compared to figuring out all of these and having to add them up. I'd rather just do 1 minus not getting 0 as 1 minus getting 0. All right, so then this one really to the 0 power, I don't have to type that in. And 3 choosing out 0, there's only one way to do that, so that's really a 1. So it's really just 1 minus that. It would be your answer for that one. All right, so there's some practice on some of the tougher probability type questions. And the big test is tomorrow. I encourage you to do your homework, which is the other worksheet in the Schoology file that we didn't do last night. And for my students, I told them if there were, it was kind of long, and so if there were a couple on there that you wanted to skip because you knew that you already knew how to do that kind, that would be fine. So get almost all of that homework done for tonight and check them with the answer keys. In Dream World, you get them all done. Check them all. All right, have a great day.